Hey there kids, welcome to Module 2, Lesson 12 video. And this one, I actually don't have notes for. It's using the standard algorithm. You can use the area model if it helps you, but I just kind of find it annoying at this point. And so today we're really going to be talking about these estimates. So the objective is to reason about the product of a whole number and a decimal with hundredths using place value understanding and estimation. So for estimation, the answer key always says answers may vary. Okay, so the estimate right here, this may vary. And so let me just point out a couple of different things that you can do to get different answers, but there's always going to be kind of a better or a bestimate, the best estimate, see, play on words, but a better estimate for, trying to get close to the actual product. So think about it this way. We're going to have, our first factor and then our second factor that are multiplied. So if I have 1.2, the thing with lesson 12 is that we're really starting to look at more than just the whole number, although we still will consider just the whole number, but you're going to have options. You are going to have options. Everyone say options, options. Yes. So let's take this 1.21, and I'll just put the 1 here because that is our whole number. So let's say we drop off the 21 hundredths, what would happen? So if we're estimating, some students will say, let's round this to 10. But I would say, gosh, if you're multiplying by 1, why not just leave it at 14? We want our estimate. We're already losing 21 hundredths. We want our estimated product to be pretty close to the actual product. So if I have 1 times 14, I can easily get the product to compare to our actual product when we do the standard algorithm. So let's just say you have options. If you thought about it differently and you said, well, I want to do 12 times 14, I would say good luck to you, but I wouldn't want to do it that way. What if you wanted to do like 12 tenths or 120 thousandths times 10? What if you wanted to round it down? Could you? Yes, you could. Okay, and again, you would be multiplying this by 10, so you would end up with 12 as an estimate. So you do have options, but let's use the standard algorithm, and then you can see how it plays out with your different choices. So 4 times 1 is 4, 4 times 2 is 8, 4 times 1 is 4. And in previous lessons, like lesson 11, we talk about what to do when you're multiplying with decimals. Now, what you do is you ignore the decimal on all these partial products. Do not put anything in. And so now that we're done with this, we're going to hold this spot with a 0, move over to the tens place, and then have 1 times 1 is 1, 1 times 2 is 2, 1 times 1 is 1. And we love multiplying with ones because it's going to be a 1 and a 2 and a 1. But of course, the 0, 1, 2, 1, 0. Add your partial products together. 8 and 1 is 9, 4 and 2 is 6, and the 1 comes down. And then what do we do with our decimal placement? So remember, if it's hundredths here, it has to be hundredths here. Old school is 2 places to the right, so 2 places to the right. New way or common core would be to label it hundredths and then multiply it by 100 to move the decimal out 2 places, and then divide by 100 to put the decimal back in 2 places. So this is what makes the dream come true for the old school, just counting your places. That's what's happening, okay? So if you look at what our estimated product was, we had maybe like a 12 or maybe a 14, but our actual answer was 16 and 94 hundredths. So 14 was a perfectly fine estimate because we're pretty close. 12 is fine too, but 14 was better. So that's where you get kind of the bestimate, which is going to vary per student. Moving down here. So what would I do? Now, again, they're giving you some numbers here that are going to perhaps challenge your thinking about, do I round it up or do I round it down? What if I wanted to make this a 2 times 300? Could I do it? Yes, I could. What if I wanted to do 250 hundredths and then multiply by 300, could I do that? So yes, you can, because what you're trying to do is just get somewhere close. Like, I know what 25 times 3 is. It's 75. It's just a matter of how many zeros and where do you place the decimal. If it's 300 times 2, then you're going to be around 600. But it's also got this 0.5. So we're going to add the zeros. So if you have 600 and then you have 750 here, because you're keeping things pretty close, then looking at the standard algorithm, you should be able to compare and see which one is better. So let's do 5 times 5 is 25, and 5 times 4 is 20 plus 2 is 22, carry the 2, and 5 times 2 is 10 plus 2 is 12. And I'm going to straighten this out because it's crooked. It's like it's falling off the page. Okay, and then hold this spot with a 0. We're done with the 1s. Move to the 10s. Now the 10s is a 0, so hold this place for all time and move over to the hundreds and start multiplying. 3 times 5 is 15. Carry the 1. 3 times 4 is 12. Plus 1 is 13. Carry the 1. 3 times 2 is 6. Plus 1 is 7. And then when we add these all up and we put our decimal back in, remember, if it's got 2 places here, it should have 2 places here. So 1, 2, 1, 2. Make a match. If you wanted to do the times 100 here, just do the divided by 100 here. So you take it out, put it back. And so the idea is you have to put it back. Now look at our estimated factors and products. So if I change this to 2 times 300, I get 600. Not bad, not bad. But look how, if you can leave this at 2.5, I think the book does not. I think this one is what the answer key says, but you can't always trust the answer key because it's just a little bit off sometimes. In fact, I think it's off today at the end. And so if you have the 25 tenths times 300, then you would have the 750, which is actually super close to our actual product. Okay, so again, you have options with your estimates, and there is going to be a better estimate, or what I call a bestimate. And then we'll straighten this out again. So some are better than others. If you're estimating, answers may vary. Then we're going to solve using the standard algorithm. So we do a 1, and then we do a 2. And use a separate sheet because look how crammed in it is. It's going to be really hard to fit it all in. So no area models here. You just won't be able to fit them. Now, looking at what we have here, I could just take this 1 and multiply by 12 and leave this alone and end up with something around 12. But I have to do the standard algorithm. So 1.23 times 12. 2 times 3 is 6, and then 4, and then 2 times 1 is 2, and then hold this spot with a 0, and then start multiplying with the 1. 1 times 3 is 3, 1 times 2 is 2, 1 times 1 is 1. It's like you're high-fiving each digit across the top. Add these partial products, that get 7 and 4 and 1, and then we have to place the decimal. Thinking about placing the decimal, this is your reasoning about the product of the whole number and the decimal and trying to figure out where to put it. If I have 12 as my estimated product, then where would I put the decimal in here? Well, making it 1.476 would be too small. 14.76 just to compare would be about right. 147 would be way too big. And of course, 1,476 means, whoops, you've totally forgot about the decimal. If I go old school and I say 1, 2 places up here in my factors, 1, 2 places down here in my product, that's how you know you are doing a good job because you're actually very close to your estimated product. Okay, let's do another one. And again, you may choose something slightly different. If you chose, say, 1.2 here and then a 10 here, then you would just move that decimal. So it's going to look a little different depending on what you choose. Okay. Now this one, again, 1.3, you don't have to use anything other than 1. You can just drop that off entirely. And since we're multiplying with 1, it's really better to just leave it like this. What if you changed it to 25? What if you changed it to 30? That would all work. It would be fine. Okay? So your estimated product is going to be either 25 or 26 or maybe 30. So you have options, but I would say that 26 might be the best one because it's very close to what we actually have. So now you can set it up either way. You can do 1.3 times 26, or you could do 26 times 1.3. It's going to work out either way because of the commutative property. Don't forget that one. 6 times 3 is 18. 6 times 1 is 6 plus 1 is 7. Hold this spot with a 0. Done with that. Move over. 2 times 3 is 6. 2 times 1 is 2. And then add our partial products. 8, 7, and 6 is 13. Carry the 1 and don't forget it. It's 3. Now we have tenths here, so we should have tenths here. Or times 10 to get the decimal out, but divide by 10 to put it back in. Okay? And so you should end up with 33 and 8 tenths. Now this one, notice, this is what they want you to do. They want you to think. There's no 1 here. It's not really even close to 1. So what should I do for my estimate? So why don't we just leave it at 2? 2 in the tenths place. Change the 3 to a 0 so that I have all zeros on either side, so I can kind of do the math in my head. If you leave it at 14, you're going to have 14 times 2 is 28. If you change 14 to 15, you would have 15 times 2 is 30. If you round it down, sometimes the book will say, oh, you can just round it down so that you get this times this, which is what we have done in the past. So that would come out to be the 2, which you should recognize, although it's been a few lessons since we've had these problems, okay? So the bestimate, according to the book, would be to do this. But you have other options if you'd like. Actual multiplication times 14. 4 times 3 is 12. 4 times 2 is 8 plus 1 is 9. You don't have to put the 0 here if you don't want to because it's just a 0. Done with the 4, move on to the 1 in the tens place. So 1 times 3 is 3, but of course it's really 10 times 3 for 30, and then move on. 1 times 2 is 2, and 1 times 0 is 0. You don't have to put it there, but you can if you want. And then add 9, 10, 11, 12, carry the 1, and 3. Now you could put the 0 here too if you want, but let's calculate where the decimal goes. Since this would be multiplying by 100, then you would divide by 100 and put it back, and you should end up with 3 and 22 hundredths. I'm looking for the answer line so I can put it back in. So let's do another one. I hope these are kind of making you think. Now, if I have 45 hundredths, what I'd like to do is just keep it as simple as possible. So I'm going to raise it up. The 5 would say, just add 1 right here to the rounding place. So I would bump it up to 50 hundredths instead of 45 hundredths. Now, with 26, that might not be easy to multiply by 5. So you could say either round up to 30, or some students might say, well, I could do 25 because I know 25 times 4 is going to be 100, so 25 times 5 is 125. And again, 25 is closer to 26. Book says, oh, but you can round it up to 30. And, and I'm saying, hey, you're going to be farther away from the actual product because you were already raising 45 hundredths to 50 hundredths. So, so we can do our 15 or 12.5. Okay, and think about it this way. 5 tenths is equal to half. 5 out of 10 pieces is half. So what's half of 30? What's half of 25? That's really what we're finding here. Now let's do the actual multiplication. I prefer putting the 3-digit one on top just so I can show the 0, but you can switch them around if you want and not have the 0, but the 0 has no value except it's 0 once. Times 26, multiply. 6 times 5 is 30, 24, 25 to 6, 27, carry the 2, and then it's 0, and then the 2 comes down. So 0, and then 5 times 2 is 10, carry the 1, 4 times 2 is 8 plus 1 is 9, and 2 times 0 is 0. So if you add all these, 9, 10, 11, you're going to end up with 11 7/10, okay, which is pretty close to what I said is like a better estimate than what the book said. But, you know, whatever. They can do that because they wrote the book. So here's a whole number. You can use the 7 because it's a whole number, and then you want to try to work with something that's easy. I'm going to move this up to a 30 because that's pretty much the easiest thing for me. 7 times 3 is 21, and we have the extra 0. So that's what I would want to do. Then we have 7.06 times 28. And 6 times 8 is 48. 8 goes down, 4 goes up. 7 times 8 is 56. And then put the 0 here, move over. 6 times 2 is 12, carry the 1, and it comes down. 7 times 2 is 14. Put that there. Add 6, 7, 9, and 1. Here we have the hundredth, so you could multiply by 100 to get it out, but don't forget to divide by 100 to put it back in. And so we have 197 68 hundredths as your actual final answer. 210 was a pretty good estimate. We're not that far off. Again, if we have 6, it's looking at both factors. 6 is a nice whole number. I can use that here. What can I multiply by? It's pretty close to 200. Okay, so let's take the 6 times 2 is 12 and put those extra 2 zeros on. And take our 6.322223 and multiply. 3 times 2 is 6, 3 times 3 is 9, 6 times 3 is 18. Hold this spot with a 0. We're done with that. Move to the 2 in the tens place. 2 times 2 is 4, 2 times 3 is 6, 2 times 6 is 12. But I still have another one. So this is the third row. Okay, 1, 2, 3. Hold this here. Go to the third position. 2 times 2 is 4. 2 times 3 is 6. 2 times 6 is 12. And I should get the same products, 1, 2, 6, 4, 0, 1, 2, 6, 4, 0, but the extra 0 because we're in the hundreds place. Okay, so check yourself. Add down 6. 9 and 4 is 13. 8 plus let's do 6 and 4 is 10, plus 8 is 18, plus 1 is 19. 6, 7, 8, 9, 10. 2, 3, 4, 1. Okay, now looking at our estimated product, I'm supposed to have something around 1,200. Think about the 2 places here, the 2 places here. Multiply by 100 up here, divide by 100 down here. And you end up with 1,409 and 36 hundredths. Okay, let's keep going. We're doing great. And again, look at these almost get easier as we go on to here at least. 7 we can use, 200 we can use. So we should get something around 1,400. And these both have zeros, so either one on top or on bottom would be fine. Let's do 7 and 6 hundredths times 208. 6 times 8 is 48. 8 goes down, 4 goes up, and then it falls down. 8 times 7 is 56. Now, we're done with the 8. Hold that. Guess what? No tens. Move over to the hundreds. Start putting your next partial product here. 2 times 6 is 12. The 2 goes down, the 1 goes up. But 2 times 0 is 0, and then the 1 just falls right down. So 2 times 6 is 12 because the 0 lets the 1 fall down. 2 times 7 is 14. But we still need that place value position. I think some of the kids are getting confused about the 0. It's like it still is holding that place, and the 1 just comes down. And then the 2 times 7 is 14. Now we can add these 2 partial products, and we have 8 and 4 and 8 and 6 and 4 and 1. And then we have hundredths here. So if you wanted to think multiply and divide, then it should go right back here. 1,468 and 48 hundredths. Last one on this page. Now we've got, of course, all the 5s. You've got all these different things you can think about. So a couple things, like if you have one go down, you could have the other go up. So let's say you have 151 and you round it up to 200. Okay, and then you could have this as 600. And then you get 6 times 2 is 12, but you still have the 1, 2 zeros from here and the 1, 2 zeros from here. Okay, so you end up with 120,000. Or you could do something like, say, go down this way and have 100 times 600 oops, 600. I can hear the janitors vacuuming. It's time to go. And then you can have 6, 1, 2, 3, 4. And then so the difference between these two, this is 120,000, this is 60,000. It's quite a difference. So let's see what actually is our product. 151 and 46 hundredths and 555. This is going to be the same product over and over. So let's do it really carefully. 6 times 5 is 30. Carry the 3. 5 times 4 is 20 plus 3 is 23. 5 times 1 is 5 plus 2 is 7. Nothing to carry. 5 times 5 is 25. 5 down, 2 up. 5 times 1 is 5 plus 2 is 7. Oops, 7. Now, this is going to happen again. So let's hold this spot with the 0 because we're done here. Now 5 times 6 is 30. There's the 0, there's the 3. Then we have 23 again. Carry the 2. 5 times 1 is 5 plus 2 is 7 again. 5 times 5 is 25 again. Carry the 2. 5 times 1 is 5 plus 2 is 7. So see, I just proved it that I'm supposed to have 7, 5, 7, 3, 0. So this time, what I'm going to do is I'm going to say 0 for the ones, 0 for the tens. Here I am in the hundreds place, and I should have 7, 5, 7, 3, 0. So backwards, back it out. 3, 7, 5, 7. So in that order, and you can do it if you want, like I'm just showing you the math way to do that. Okay, so then zeros come down, and 3 comes down, and 7 and 3 is 10. And then 7 and 3 is 10 again, 15, 16. And then 14 plus 1 is 15, plus 5 is 20. And then I have 12, 13, 14, carry the 1, and 8. Now I have hundredths here, so I should have hundredths here. This is a rather large answer, 84,060 and 30 hundredths. So I'm actually closer here. Well, I'm pretty close, but I'm in between. I'm closer to the 60,000 than I am to 120,000. So this is a better estimate. I think the book says use this one. So again, you can be close. You'll be okay if you're even off by like 40,000, and I'm rounding. Okay, so let's move on to the word problems. Denise walks on the beach every afternoon. In the month of July, she walked 3 and 45 hundredths miles each day. How far did Denise walk during the month of July? One thing you need to know is that July has 31 days. Okay, and that's something that kids will always ask. There are 31 days in July. So take your daily amount, 3.45, and then multiply by 31. 1 times everything is going to be 3, 4, 5, because 1 times 5 is 5, 1 times 4 is 4, 1 times 3 is 3. So just like that. Hold this spot with a 0, done. Let's multiply with 3 tens. 3 times 5 is 15. Carry the 1, then we have 12 plus 1 is 13. Carry the 1, 3 times 3 is 9, plus 1 is 10. Add, 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 add. There's nothing to add there. Then we have, of course, the multiply by 100, divide by 100. And so I have 106 and 90.95, but let's label it. She walked 106.95 miles in July. Wow, kudos. Okay, there you go. So that is number 3, and then we'll do number 4. A gallon of gas. Oh yeah, if these videos are helpful, and I sure hope they are, then click subscribe and come back again. Okay, a gallon of gas costs $4.34. Greg puts 12 gallons of gas in his car. He has a $50 bill. Wow, lucky Greg, because I never have 50s, but thank you very much. Tell how much money Greg will have left or how much money he will need. Show all your calculations. So let's check out the $4.34. Seems like California gas prices to me. And times 12, because he's putting in 12 gallons. 4 times 2 is 8, 2 times 3 is 6, 2 times 4 is 8 again. Hold this spot with a 0. We're moving on to the tens place. 1 times 4 is 4, 1 times 3 is 3, 1 times 4 is 4. 1 times 4, 34 should be 4 for 34. And then let's add. 8 comes down, 6 and 4 is 10, carry the 1, 8, 9, 10, 11, 12, and 5. times 100, divide by 100, or 1, 2 here, 1, 2 here. So $52.08 is what? Well, that's the cost of gas, okay, that Greg put in the car. But we need to know how much more money or how much he will have left, because he has a 50. So since the gas costs $52.08, okay, we know that he doesn't have enough, and so how much more will he need? You would find the difference by doing subtraction. It's really easy to subtract when you have all the zeros down on the bottom. So the simple difference is $2.08, and so Greg will need $2.08 more. Okay, label your work. And finally, oh, don't sing. Finally, Seth drinks a glass of orange juice every day that contains 6/10 grams. Oh, this is the one in the answer key that we're laughing. We're like, okay, well, we cannot get that no matter how hard we try, so we're going to have the right answer here, not what it says in the key. Vitamin C, good. Eat your vitamins and drink them. He eats a serving of strawberries for a snack after school every day that contains 3,500 grams of vitamin C. How many grams of vitamin C does Seth consume in 3 weeks? So let's take a look at this 3 weeks. How many days are in 3 weeks? So if you have 7 days a week times 3 weeks, we're going to get 21 days. So there are a couple ways that you can do this, a couple schools of thought. Students will do it differently, and both ways are right. I've seen students very happily share their work. Now, what you can do one way, you could do the daily intake. And you could do, for example, the 6/10 plus the 3,500 to find out the total that Seth, the grams each day. And then take that. We know that we have to have 21 days, so we're going to do the 9,500 times 21. This is one way. Okay, so if we show it like this, then multiply it, and of course 1 times 5 and 1 times 9 and 1 times 0, that should be really easy. Hold that with the 0. 2 times 5 is 10. 2 times 9 is 18 plus 1 is 19. Add those up. And it's 2 decimal places here. So it would be 19 and 95 hundredths grams of vitamin C. Now, if you don't really see it that way, you could take each of the items that Seth has and take the 0 and 6/10 times 21. That's too smashy. I can't stand it. Okay, 21 times 0 and 6/10, and you can multiply it and then add your two totals. 6 times 1 is 6, 6 times 2 is 12. That is 12 and 6/10 for the OJ grams. And then the strawberries would be the 3,500, and that's going to be times 21. And then we have the, of course, times 1. We have 5 and 3. Hold that. And then we have 10, 6, and 7. And then we have 7 and 3 and 5. And then we're going to add these together, the 12 and 6/10, and the 7, be careful when lining up, and 3,500. And then just add, line up everything, decimal down, 9 and 19. And so either way, you get 19 and 95 grams of vitamin C. And I hope this has been so helpful. And come back again. We'll see you on another video. Bye for now.